In the next 5 minutes, we're going to build a working text embedding pipeline end-to-end using Azure OpenAI and Python. By the end, you'll know how to deploy an embedding model, authenticate without leaking keys, call the Embeddings API correctly, batch and chunk your text, and push the vectors into Azure AI Search so you can do semantic retrieval. I'll call out the real decision at each step and what to verify when it's running. Let's wire it up. Here's the shape of it. Your Python app authenticates against an Azure OpenAI resource where you've deployed an embedding model. Raw documents live in blob storage. The app reads them, sends text to the embeddings endpoint, gets back float vectors, and writes those vectors into an Azure AI Search index. At query time, the same model embeds the user's question. An AI search does the vector similarity match. One model, used for both indexing and querying. Keep that symmetry, the query and the documents must be embedded by the same model and dimensions. First, the model. Create or pick an Azure OpenAI resource, then create a model deployment. Today the workhorse is text embedding 3 large, which outputs 3072 dimensions, or text embedding 3 small at 1536 for cheaper, faster jobs. The deployment name you choose is what your code references. It is not the same as the model name, and that trips people up constantly. Note the region and quota, because embedding throughput is rate limited in tokens per minute. Model availability shifts often, so check the current Azure OpenAI model docs before you commit. Now the code. Skip API keys, use Microsoft Entra ID with DefaultAzureCredential, and grant your identity the Cognitive Services OpenAI user role. The Python client wraps token acquisition for you. You call embeddings.create, passing the deployment name as the model parameter and a list of input strings. The response gives you one vector per input. Notice you can pass a list, that's your batching lever, which we'll use next. 3 decisions make or break this. First, chunking. Split documents into roughly 500 to 1000 token passages with some overlap, because embedding a whole document blurs the meaning. Second, batching. Send many chunks per request, a few hundred is fine, to amortize latency and stay under your tokens per minute limit with retry and backoff on 429 responses. Third, dimensions. The text embedding 3 models support a dimensions parameter to shrink vectors, say to 512, which cuts storage and search cost with a small accuracy trade-off. Pick one dimension count and never mix. Now persist them. In Azure AI Search, define an index with a field of type collection of single, set its vector dimensions to match your model exactly, and attach an HNSW vector profile for approximate nearest neighbor search. Upsert documents carrying the vector plus the original text and any metadata you want to filter on. Keep the source text alongside the vector. You'll need it to return real content to the user, not just an ID. How do you know it's right? First, assert the return vector length equals your configured dimensions. A mismatch means a wrong deployment or stale config. Second, sanity check semantics. Embed 2 similar sentences and 2 unrelated ones. Compute cosine similarity and confirm the related pair scores higher. Third, run a real query through AI Search and eyeball the top hits for relevance. Finally, watch your Azure OpenAI metrics for throttling and token usage so you can size quota before production. So the full path: deploy text embedding 3, authenticate with Entra ID, chunk and batch your text, embed it, and store the vectors in Azure AI Search with matching dimensions. Then verify with length checks and a cosine test. The one thing to lock in your memory: the deployment name, the dimension count, and the model must be identical for both indexing and querying. That single consistency rule prevents the most common bugs. Pricing and model versions change, so confirm against the current Azure docs before you ship. Build it once and it becomes the foundation for every retrieval feature you add. If this helped, Do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.